Okay, finally, the analogizers. So as I mentioned, the basic idea of the analogizers is that everything that we do, everything that we learn, is reasoning by analogy. It's looking at similarities between the new situation that we need to make a decision in and the situations that we're already familiar with. Okay? And one of the early pioneers in this area was Peter Hart. He proved some things related to the nearest neighbor algorithm, which we'll see shortly, which is kind of like the first, similarity-based algorithm. Vladimir Vapnik is the inventor of support vector machines, aka kernel machines, which is the most widely used and most successful type of similarity-based learner. But these are both actually still fairly primitive forms of analogical reasoning. There are some much more sophisticated ones that people like, for example, Douglas Hofstadter work on. And Douglas Hofstadter, of course, is also famous. He's not just a cognitive scientist and computer scientist. He's also famous as the author of Gödel, Escher, Bach, which ironically is actually itself an extended analogy between Gödel's theorem and the music of Bach and the art of Escher. And in fact, his most recent book is 500 pages arguing that all of intelligence is just analogy. So he really does think that analogy is the master algorithm. And in fact, the term analogizer was coined by him. Okay? So let's see how this works. And I'm going to do it by proposing to you a very small puzzle. And the puzzle is this. Let's suppose I give you a map of two countries, which I fancifully called Posistan and Negaland because of positive and negative examples. And I don't tell you where the frontier between the two countries is. I just tell you where the major cities are. So the major cities in Posistan are the plus signs, Positiveville is the capital, and similarly for the negative cities. Okay? And now my question to you is the following. If I only tell you where the major cities are, can you tell me where the frontier, where the border between the two countries is? Okay? Of course, you can't know for sure, right? Because the cities don't determine the border, but that's what the machine learning problem is, right? You have to generalize. Now, the nearest neighbor algorithm has a very simple answer to this question. It just says, I'm going to assume that a point on the map is in Posistan if it's closer to some positive city than to any negative city. Okay? And the effect that this has is to divide the map into the neighborhood of each city, and then Posistan is just the union of the neighborhoods of the positive cities. The neighborhood of a city is the points that are closer to it than to any other city. Okay? And then as a result, you get this jagged straight line frontier. And what's remarkable about this is that even though the nearest neighbor algorithm is extremely simple, in fact, at learning time, it doesn't do anything, right? It's an O of 0 algorithm. It just sits there, doesn't have to do anything, right? It can actually form very, very complicated frontiers. In fact, if you give it enough data, it'll converge very closely. In fact, it'll converge to the best possible hypothesis that you could ever have if you use more than one neighbor, but let's not go into those details, okay?